Hello friends, welcome to ML with AP. In last two videos we learned about iterators and comprehensions, and I promised that today we are going to build our intuition on top of iterators and comprehension, and we'll try to understand and explain what generators are. So generators are another key concepts in Python, and they are very useful in some context. So let's try to see what generators are. So generators actually are, we are going to learn two flavors. So one is generator expressions and the other is what is called generator functions. Okay. These are somewhere related, and we'll try to see these two. If you understand these two concepts, generator expressions and generator function, we'll completely be able to understand what generators are. So let's first try to understand generator expressions. Okay, and what are generators? Friends, we already know what are iterators, right? These are iterable objects, it has container data type, and it is something to be looped over, right? Iterators. Now, generators are also very similar to iterators. There is one crucial difference over here, okay? And that crucial difference is generators are lazy, while iterators are eager. Now let's try to understand what I meant by this. This is not lazy as we understand in human terms. Lazy, the execution is lazy, while iterators are eager. What is meant by it? Let's try to see clearly that why I'm saying lazy and eager. Lazy is something which is executed, or we can say executed or produced. Produced is the right word. Produced just in time when it is needed. Eager, completed beforehand. Okay, so let's take some examples so that we can understand, right? So lazy is something that if you are going to ask someone, let's take an example from our common life. You have a friend and you ask a favor to him or her, right? Then if his execution is lazy, then that person will wait for you to ask, and just in that time it will prepare and give it to you. An eager friend, on the other hand, will anticipate it, will keep it ready, and as soon as you ask, it will give you the whole thing. Okay? So let's try to see. This is some rudimentary example from the common life, but probably it will become more clear, okay, when we go through the IPython notebook, Jupyter notebooks. Okay. The other thing is over here. Let me just try to draw. Let's see if this is an example of an iterator. This is an iterator. Then generators are a subset of that. What does it mean? That means all iterators are not generators, but all generators are iterators. So as you can see from this Venn diagram also, the generator is a subclass of iterator, right? So if you have the iterator comprehension, not all iterators will be generators, but all generators will be iterators. That's also one of the crucial difference. Okay. Now let's go with what is list comprehension. We have already seen. Let's go and jump. That is what is a generator comprehension. Let's go to our IPython notebook over here. Okay, let's see. Let's first revise what our list comprehension was. So if I have to produce my favorite example of a square for I in range 10, right? This was the example or working example. If I do, it produces me the square. Range is a iterable object from 0 to 9. It gives me the square of 0 to 9, right? No problem. Okay. Now what is this generator expression? In generator expression, we do not have to use a square bracket, but use parenthesis and write in the similar way. So I square 2 for I in range 10. Okay, invalid syntax. Okay, I said in is a keyword. Okay, friends, one thing to notice over here is that when I did a list expression, it gave me the value. When I did a generator expression, it gave me an object with a generator type object, but it didn't print out anything. Now this will give you a hint that why I'm calling it a lazy execution, because it is not executing and generating it at that moment to me. In case of list expression, this is eager execution. It has already generated the list and shown it to me. But in case of generator, lazy execution, only generated the object, but it is not showing me. So when I'm going to ask it, it will produce. But for now, it has just done it has created an object, right? Okay. Now let me copy this and see that, and just to prove, I'm going to store this into a variable G. Let's see the type of G. The G is a generator type object, right? Now if I do this in L and I do a type of L, what it will be? It will be a list type of object. So this was a list expression, this is a generator expression. But if I have to prove that this and this are equally the same, I will go ahead and generate, or I'll ask generator to give me all the objects of this comprehension. And the way to do it will be, I will pass it through a list construct. Okay, list constructor, and see, in no time it has given me my my list, right? Which is, and just to make sure, this list and this list are both the same, right? Let me create more spaces over here. This list and this list are both same. Okay, so in summary, list expressions are eager, generator expressions are lazy by nature. They generate the same thing. In case of generator, it is lazy execution, it is only generating an object for me. In case of list, it is a eager execution, and it generated the whole list and gave it to me. Now friends, think where these things can be useful. Okay, now what could be the possible use case of a generator? Okay, so generator are very useful in some of the scenarios, right? Let's say, friends, if you have to read a let's say a file, a data file, which is huge. If you are going to store that file into memory, your entire computer or laptop's memory will get exhausted, right? But if you are reading that into a generator and then processing it, then generator is going to fetch each line of that file or each row of the data file one by one when you need it, and you can process it. In that way, even if the size of the data file, theoretically speaking, is infinite, you can still process it. But in case of list expression or any other method, right, which is provided by Python, you cannot do that. And that's the beauty of generator expressions, right? So if something is too big and you have to read it over there, or there is a stream of data which is coming up which is infinite, right? There is no end to it, but you do not need everything at one single time, but you want to process it chunk by chunk. In those cases, generator expressions or generator functions are very important and crucial. Okay, now that is one of the uses of generator expressions. Okay, now let's see one more example just to solidify this particular idea, right? So let's see our original list comprehension, which is I for I in range 10. Okay, and then this generated a list. If I have to iterate it over, then I will do it for I, or let's say in this case j, in L print j. Okay, it is going to print me all the things, right? This is how I constructed a list expression, and then I iterated it over. In case of generator, what I will do here also, I am going to do the similar thing, right? Let me just copy paste this particular thing inside a small parenthesis. Okay, and if I have to iterate it over, what I will do, again the same thing. Okay, let me copy. I'm just changing my list to a generator object. Okay, then I'm going to write. This also generated exactly the same fashion. What was the difference over here? In first case, in this particular case, it didn't generate the list at the very beginning or the iterator at the very beginning. What it does is, when my for loop is asking, requesting for it, it is going and fetching it, right? The recipe, the process, it is going and fetching it continuously over here. In this particular case, it generated the whole thing at once. In this case, generated just in time, lazily, right? So this is the whole idea of this generator. Now again, if I have to see the value of this is type G, but type generator. But if I have to see the value of this was my list, right? So this is the difference between list comprehension and generator comprehension, right? Now, as I was saying, again reiterating, the use case could be various. If you have to read large data files, some sort of infinite streaming data, if you have to read, at those places generators are very, very useful. Okay, and it is not limited by how much memory or disk you have available. You are only reading one by one, right? Now friends, one question will come in your mind that, hey, how come this generator is able to do that, right? And it is able to read one by one. So for that, we have to go into generator expression. But before that, one more concept let's try to understand. Okay, now if generator by nature is lazy, so if I have exhausted this, I have to instantiate it one more time before I can read. Now let's try to understand it with an example, that what I am trying to tell. Okay, over here. Okay, this particular thing, again I will paste it over here. Let me execute it. Okay, and then I am trying to make a list constructor so that I will be able to print this G. Okay, I printed G. Now here is the tricky thing, right? And this will make you understand that what I'm trying to tell. If I'm going to print one more time list G, what will happen over here? Let me print this. See, it is printing an empty list. What happened? What happened over here? Think for a moment. I constructed a generator expression. So a generator object was created. I utilized the generator object in constructing a list out of it. It is one-time use. Friends, remember, the crucial difference between generator and list is list can be utilized multiple times. All the things are stored. In generator, it is one-time use and generated just in time, lazily. So if I have already generated or exhausted this particular generator, next time again I am calling, it is returning me an empty list. If I execute again this line number 60 one more time, and then I do a list over here, you can see that it is generating me the number. Okay, so this is the, but in case of list, I have done my list over here. Let's see, list, right? Let me print the list. Let me print the list. Let me print the list. Every time it is printing the same. It's the static list, right? It's the static list which I'm printing. But in case of generator, it is not. It is one-time use, exhausted. So two critical difference, just to rephrase. One is lazy versus eager execution. The second is one-time use versus many-time use, right? That is the crucial difference. Okay. Now let's see some more interesting thing about now when we are saying that this thing is one-time execution, then thought would come to your mind that hey, how it is able to do that, right? Is it maintaining some internal counter or something like that for the generator? So let's see that particular thing with an example which will make it more clear that why this generator or generator expression or generator function, why it is different from expressions, normal expressions or normal functions also. Okay, now let me just write an example. Okay, I will copy the same thing. Let me copy the generator expression from here. Okay, and I'm going to ask, okay, this was already exhausted. I'm going to ask for the first element. It gave me the first element as 0. 0 was my first element over here, right? As you can see, 0 was my first element. Now if I execute next G one more time, right? Rather than copy over here, it will give me 2, it will give me 3 and 4. Okay, so 0 1 4. Now one question will come to your mind that hey, if I am doing this next every time, you have told me that this generator is a lazy execution, so it is executing just in time, right? When I'm doing this next operation between here and here, there were a couple of seconds which were passed, so control came out. Still when I am going to do this, it is fetching me the next record. So is Python maintaining that thing internally somewhere? The answer is yes. In case of list expression, no. In case of generator expressions, it maintains an internal state. So it knows till when I have already exhausted the counter, and it will start giving me the next value after that. Okay, the way it works is that this generator expression, this thing it gets frozen when I did a next G. After that, I can do many operations. The state of this gets recorded inside Python, and when I do the next G over here, again those particular values, Python knows that from till what extent I have already consumed the generator expression and what is left over there, and it is going to produce and give me the next value. This sometimes becomes very interesting, and some use cases can be solved. Let's say in a program, if you have to such a use case that you have a lot of streaming data, but if you encounter something, or if you encounter a particular line in a text file, which a very big text file you are reading, and you encounter a particular line, then you have to do something else. You go and do something else. Again, when you go and you come back and you start reading from that particular generator, it will start giving you the next value. Okay, so just to summarize, there are 3 important differences. The first one is lazy versus eager. The second difference was it is one time use versus multiple time use. The third one is, which we are just seeing over here, that you can pause it in between, right? In case of list and all, no, you cannot do that. Python doesn't internally will maintain the state till what time you have read, till what point you have read. Here you can pause and unpause it in that way, right? Okay, and friends, remember that every generator is an iterator, but not vice versa. Okay, now let's go and see. We are talking about generator expression. We have already seen generator expression. We are talking about the generator functions. Like, what are generator functions? So generator functions just look like normal functions. There is only one difference. Okay, and the difference between generator functions and normal functions. Obviously, generator function generates a generator object. That is fine. But one critical difference is that in normal function, we have return, as you have seen, right? But in generator function, we have yield. What does yield means? In normal English, that gives something, like, okay, I give you something. So generator functions yield something. So it has to yield the object, iterable object, one by one. While in case of normal function, it just executes the function and returns everything in one go, right? So friends, I think you are getting the intuition that why generators are lazy executions. It is giving one by one instead of functions or list expressions, which is throwing everything at one time, and how it is memory efficient and disk efficient, right? So I hope you are getting those intuitions over here, right? Now let's go ahead and see an example uh, of how yield works, right? So when Python yield statement is hit, let's say I'm writing a generator functions, and when the Python yield statement is hit, what the program will do, it will suspend function executions and return the yielded value to the calling object, right? So whoever is calling, I will return the value. But in case of normal function, if return, the complete program ends, the function ends in one go. You have to call the function again. But here, over here, the keyword is suspended. So in case of generator function, the function is suspended till the function is called next time. In case of normal function, everything return, the function ends. Okay, the execution completes. So that's the critical difference. Okay. So how it maintains? When we suspend, then like how we know in the in computer technology also, that something is suspended, that means it is frozen in time. Again, it will be awakened. All the variables, all the internal variables for that particular generator function will be revoked, and it will start from that particular point onwards where it was suspended, not from the beginning, like in case of normal function. When it is invoked at that particular, and it will yield one by one. So friends, this generator function is also something very similar to generator expressions. The intuition is very similar. Let's see it with an example, and then it will become clear. Let's see our favorite thing. I don't know if, okay, it is not there. Okay, let me write it down. So I will write first an expression, okay, and then we'll write a function, generator function. This is my expression, and I'm going to, the counterpart of that will be the generator. Let me define this is also used with the def keyword, and I'm writing a custom function, gen for I in range 10 yield. I will use the keyword yield, which I have been talking about. Yield square 2. Okay, that's it. That's it. Okay, so in this particular case, let me quantify this as G1. Okay, I executed cell number 74. Let's see the type of G1. It is a generator object through a generator expressions. Okay, now let me call this. Let me first execute this generator. Yeah, the generator function is executed. Let me call this function and store the return value into, let's say, y. Okay, what is my type of y? My type of y is generator. Again, this is also given generator, similar thing as G1, right? Okay, this is also giving my generator. Now if this is my generator object, if I do, let me make more space, if I do next G1, which I did through an expression, what it will return? 0. Again next G1, 1. Again next G1, 4, right? Now let me do the same thing for my y. My y is done through the generator function. 0, 1, 2, 4, right? So it is also generating the same thing as this function. This is the generator function. What is happening over here? When I'm doing this next, at that time it is going, executing this, getting me the next value in queue over here, again suspends this particular generator function, comes back, displays the result. Now if I do again one more time, 9, it is maintaining the state. In case of normal function, friends, it will never maintain the state, right? But over here in generator function, it is suspending, maintaining the state, awakening again, getting the new value. All this is happening because of the yield keyword is provided over here, which let Python identify that this is a generator function. If I would have passed return over here in this particular case, let me show you just. I'll change the name and return. Okay. And this has to be and let me call gen1 over here 0, right? So why? Because I in range 10, the first value went over here and it returned gen, right? 0. If I have to call this again, is it producing any new value? No, it is producing the same value, right? Yeah. Okay. I could have done, just to make it little more similar, is I would have done that l dot append I return. Okay. So if you see over here, this will be more similar example. Again over here, what I'm doing nothing fancy. I'm getting a I in range 10. I'm appending the squares of it. I'm appending it into an empty list and I'm returning it over here, right? With a return statement, right? And when I'm executing gen1, it is giving me a square, right? From 0 to 81, right? If I execute gen1 again over here, it is appending because okay, this list was there, it is appending. It is not freezing, unfreezing, anything like that, right? This, when gen1 is called, this whole function is executed in totality, in complete, right? Next time I have to execute one more time. And why it is appending? Because I was using the append over here. The L was already there, it appended one more time over here. Okay, but see the difference and the beauty over here in this particular, in case of yield, and because it's a yield keyword, it is identified as a generator function, it is getting suspended. Okay, so when I'm calling this next g1, okay, it is fetching me, not next, yeah, ygen, type y, and if I'm fetching this type y next time, next execution, but it will also exhaust. Okay, and let's see what will happen. By now you must have a guess that what happens. It has stopped because it exhausted. It has stopped iterating over here. If I have to again execute it one more time, I have to define this generator object and then start doing one more time. Okay, this, and let me do this also. And if I do a next y over here, it will start again going through the loop. So generator functions like generator comprehension, one time use, right? And it suspends. So comprehension and functions, they're just different way of implementing the similar thing, right? Okay, I hope guys this generator expressions are very clear. One thing which I have already told you and never proved it is that they are very efficient. Intuitively it makes sense that it is efficient. Why it will be? Because it is not reading the whole thing, it is reading one line at a time, one row at a time, right? In case of data file, let's say I have a big CSV file, and if I have to read, I'll read one observation and one row at a time, right? Intuitively it makes sense, right? But we have never proven that that is the case. Now recently OpenAI has launched a ChatGPT. I'm sure that all of you have seen. I was trying to play around with you and I thought that okay, why not ask ChatGPT and see that how it does. Just as an interesting experiment, I let me show you. So what I did was I wrote to ChatGPT that write a Python program to show generator function takes less memory than normal function with examples. And it is so powerful and good that it generated exactly what I wanted, right? So let's copy this code and let's see what it is doing, what ChatGPT has generated. Okay, and that will conclusively prove that why it is. So it is importing a sys module. Sys module is usually used to, if you want to have that operating system level data like memory, disk, and all those things, you will import the sys module. Okay. Now it is defining two functions. One is the normal function, and what it is doing? It is defining an empty list for I in range n, numbers.append I. It is appending that list and it is returning the number, right? This all it is doing. Very similar to what we were doing, right? The next what it is doing is it is creating a generator function also. Very similar to what we have done over here, generator function, right? So it is doing a generator functions also. The second function is a generator function for I in range n yield I. Now it is trying to get the memory usage for the normal function. It is passing a variable here, nn. It is defining n as 100,000. Yeah, I think it is 100,000 or 1 million, a large number. It is defining it. When it executes the normal function and it is put it in normal numbers. So whatever is returned, it has put it into normal numbers. In and normal numbers, it is trying to get the size of. This get size of gets implemented through sys module. So sys module has a method get size of, which gets the size of. So in normal numbers, it is getting that how much is the normal number, and those numbers obviously will be stored where? In memory, right? So it is calling a variable normal memory, right? So whatever is returned from here stored in memory, it is getting the size of. Similarly, it is going for the generator function also, and it is getting its size also. Okay, and it is printing. Nothing fancy, it is just printing that. Let me run this program. And this program is working also. Good ChatGPT. Normal function memory usage is these many bytes. Generator function memory usage is 112 bytes. Now you tell me, friends, that why it is 112 versus 8 million. And the difference is that in this particular function, it is not generating the list. It is not returning the list. It has only created the object, right? It is only created the object. And when you do next or iterate it over, it will just in time, it will create and fetch and give it to you every time. That's it. Over here, what it is doing, it is created the whole list, numbers list. Okay. And it is returning. That's what the size is this. Okay. So it was a very short, sweet example to prove that why generator functions or generator expressions for that matter are more efficient memory and disk wise than the normal function or list expressions, right? I hope you like this video, friends. With that being said, I think we have come to end of the generator expressions and generator functions. Yeah, if you have any question or comment, please do put into the comment section. I will try to answer that. If you like these type of content, I will try to make more of the Python series. I also intend to make machine learning or deep learning videos. If you are interested in those, please do comment over there and let me know. I will try to make that. Thank you, friends. This is ML with AP signing off. Thank you.